Welcome to the webinar. We're delighted to have you here and join us today. My name is Martin Reiners and I will be the host for the next 4 hours for you. No, just a joke. It will be about 25 minutes. I know that in France it's around lunchtime, so I have to hurry. So let's get started. My company is enesty from Germany, from Saxony, but the product I'm talking today is the orcinus. And just a short look at the program of our company enesty. We're making injection molds, temperature control systems, and cooling systems. This is what I will introduce to you today. But also we have additive manufacturing and close contour cooling. And here we have our product family, which is called orcinus. And included to that is the orcinus-Orca system, which I will introduce to you today. And the little brother or sister is the Smart Shark system. So I will start my timer that I don't miss the target of 25 minutes. Here you can see our footprint around the world. We're having a strong network of partner companies such as Matsui for the Asian area, such as India, China, Japan, but also North America, Mexico, and of course, a lot of Europe. We're talking about temperature control today. So let me first of all introduce you the potentials of the temperature control. And here, don't worry, I don't want to make it too much of a maths lesson, but to explain the potential, we have to talk or have a short view at this formula, because overall it is the cooling time which is part of the price of a plastic part. So you have to understand that the German word for cooling is with K. So this is why there's a K in English. This should be a C. So the cooling time formula is pretty much affected by this. And this is the tool wall temperature. And this is the only term of the whole formula we can affect, because the rest, like the melting temperature, is given by the material. So we are looking today at the tool wall temperature because this is a huge part of the cooling time. Here is one sample calculation for, in this case, polycarbonate. And when you're calculating the price of your plastic part, you have a theoretical cooling time for this of 10.5 seconds, because you measured with a, for example, infrared thermometer, a mold wall temperature from 80 degrees Celsius. But this is outside of the cavity. So you say we should have a 10-second cooling time, which then defines the price of your part. But in practice, the mold wall temperature is much higher. In this case, 30 degrees more, which increases incredibly your cooling time, almost 30 seconds. With the auxiliary time, it's 34 seconds to be precise. And this is more than 150% longer than you calculated. And when you look at 500,000 cycle, then it is a lot more. almost approximately 19 weeks of working time more. So this is the reason why we're talking about the potential of the cooling time, because 19 weeks of working time is, I think you understand, a lot. So let's look at some typical temperature controls, which I found in the field when I'm visiting customers. For example, we have an injection mold machine and one TCU, so one temperature control unit, which is connected to the mold. And then the water is cooling down the mold during the process. It is very easy to connect one hose to the mold. It is quick. You can't do it wrong, almost. But some customers do it with two TCUs because they say, I want to have one hose for the injection side and one for the moving side. But the idea is the same. The water goes inside the mold and comes out a bit warmer. So we call this a serial connection. And in practice, we see a lot of bridges. What does that mean? The bridges have an effect because it is only one connection with fresh temperatured water incoming. And with every single circuit, the temperature is increasing, which makes the delta T from here to here, so from ingoing water to outgoing water, high. So about 7, 8, or even 10 degrees difference. This has some disadvantages. So you can see, for example, the pressure drop of such a long cooling channel. We have it here in 2 meters, 4 meters, or 6 meters. And here is the pressure drop on the left. So you see, if you have, for example, 4 meters of cooling channel, you already lose everything of your pressure, because I don't think you have much more than 6 bar in your system, in the cooling system. So this is with a 6 millimeter diameter, which is very common, I think. But if you could use a 10 millimeter, then it will be not so impressive like here when you lose 6 bar. So what we want to show you is that the longer the cooling channel is, the more pressure drop you have. And together with the effect that the temperature of the water is increasing so much, you have a not very effective cooling. So we have it here summarized: increases of the pressure drop, and with the bridges, you have a problem with your flow and the pressure. So the temperature inside the mold is not always the same. So because on the lower side or close to the outgoing side, it is much warmer. And this increases your cooling time and the cycle, of course. And this results in higher cost per part. So some customers say, then I need more TCUs. and this is a picture we made at our customer, and we saw it very often. The customer say, okay, I buy a lot of TCUs, which makes the TCU provider happy, but it's not such a good solution, because you have to spend, even if it's 2,500 euro each, it is more than 20,000 euro only for this. And you need a lot of hoses to connect it to the mold. You have a lot of maintenance costs. You need a lot of energy to run all these TCUs. And so it is, for our opinion, not the best solution to help you to have a stable process. Because every time you change the mold, you have to set for each of the TCUs, you have to set a new temperature, which makes it not very comfortable. So the solution we are offering is the parallel distribution. So every single circuit in the mold has its own freshly temperatured water. So you see the temperature of the mold is almost everywhere the same. And the delta T from ingoing to outgoing water temperature is not so high. This is a summary of the benefits, but I think I already mentioned. One problem is that water always seeks the path of the least resistance. It's like in politics. So we are offering our orcinus solution, which measures for every single circuit the temperature and the flow. So we're having two manifolds, one for the incoming fresh temperatured water. Then it's going inside the mold, it's heating up, it's becoming warmer. And on the way back out of the mold, we're measuring the flow. This is how we exactly know what's happening inside. When you're measuring what's going inside to the mold, you have no idea what's happening inside. But we want to know, as I explained with the formula. We need to have a precise wall temperature so that we can say how long is our cooling time and what's happening inside the mold. This is how you can use our system. It's usable on both sides of the machine and of both sides of the tool. So moving or injection side, like you can see here. And this is just a sample of 4 circuit manifolds. I will come to it later. We have different sizes. This is a picture of one of our customers where we already installed the orcinus system. And some guys from the audience will miss something here. I know in a later picture you will be more satisfied. Here you can see 2 numbers on the sensors of our orcinus system, and I will explain you shortly. The red one is the status quo of what's happening actually. So this is the measured flow. Actually, we have 0.3 liters per minute, or 0.9 or 10. So it's always live, shown on the sensor. And also it is shown on the monitor, which I will explain later. And here you have a additional supplement, multi-coupling, which makes it really reproducible, the process, because every time you have a mold change, the distance from the manifold to the mold is the same because you always use the same length of hoses. You have always the same diameter of hoses. So the pressure drop and the heat loss, it's always the same. And with the multi-couplings, for example, this is the multi-coupling for the water. you are very fast and you can't make any mistakes. So it's a very good supplement to our manifold. Here you see a system during the installation. So the hoses are still missing. We're offering to our customers that we can install it at your production site, or you can make it on your own if you want to. Here you see that there are two different pairs of hoses coming to different manifolds. This could mean that the customer wants to have different temperatures at the mold, which is very common. And so from different TCUs, you can manifold different temperatures. So every manifold gets its own hoses. So I think this is a different temperature. You can see the red light, or it's turning green if you have flow. So when you're passing by your machine and you see I have the perfect flow, then it's like in traffic, you have green light and you know everything's fine with my temperature, so the process should be stable. We are measuring contactless. I will explain in the next slide. Our system is completely maintenance-free, so once installed, you never will have any issues with it. And of course, it's not a rocket, so it's intuitive and very simple to use. Here, this picture shows to you why we are maintenance-free, and it is the biggest advantage that it is a contactless measuring, which means the quality of your cooling water. By the way, it's also possible to use the system with cooling oil. It's not affecting the sensor because it's not touching it. So if you have any quality issues with your water, then our orcinus system is not affected by it because we're not measuring inside, but outside. So you don't have any pressure drops and of course, no problems with the sensor. And as shown on the pictures before, you can see the actual flow and you can see the minimum of flow you need to have for a stable process. You can define it on our screen. I will show you. And as long as the flow is higher than the minimum, you have green light on this screen and as well on our monitor. So as I said, when you pass by your machine, you can see everything's fine. We provide different sizes of manifolds from 2 to 12 circuits. You can choose and you can combine different manifolds as well. So the biggest machine we equipped was with 144 circuits. So this is not very common, but it is possible. We have a standard size and for smaller machines, a slim size. And when you need a lot of flow, then we have a maximum size. It's all in the catalog, very easy. Then we have two variants with standalone, which means it's in the after sales implemented or fully integrated. Then you don't have a monitor from us. You can use the monitor from the injection mold machine. And our manifold is based on the principle, as I explained, of the parallel distribution. Here you can see our monitor. So this is a standalone version. and always shown as liter per minute or degrees Celsius. But here in the settings, you can change it to gallons per minute and Fahrenheit as well. So you can change different languages and from metric to imperial measuring system. This is the number of the circuits. And if you have 144 circuits, you have to push very often this button. So fortunately, it's only 6 actually, or 12 in this case. And you can see the status quo of the flow and the temperature. And all numbers are green because we set a minimum flow, which is under the actual flow, and a maximum temperature. And actually, the temperature is under the maximum, so we have green numbers, which means everything's okay. And at this time, if you can look at the sensors, they will be green as well. Here, you can set your tolerance window. You know your process and you know which temperature do I need to have a perfect quality of my parts. And you know flow and temperature, which makes perfect parts, so you can define it. Here you can save for every single mold, you can save the recipe. So after a mold change, you just load the new recipe for the mold, in this case 2520, and then you will have all the numbers stored. This is the place where you can see if you had any alarm, in which circle it has been, which is very comfortable because you can say to the mold maintenance guys, oh, please look at channel 8, I have an issue with it. So these guys don't have to look and search for the problem. This is very comfortable. So the alarm outputs give you the situation if one of these terms will turn to red, then you will have an alarm output to the injection mold machine and the machine will stop. Because anything you will produce from now on would be not in the perfect quality. So this gives you the situation that you have a insurance always to have perfect quality. And when you're looking inside your mold and you can see every single circuit's temperature and flow, you can see what's possible. So you can play a bit with this. And this is how you can shorten your cycle time as well. Because when you realize, oh, in this circuit, there's 8.9, but it should be 20, you know, something's missing. So you can look for the reasons. And when you fix this problem, then you might have a much smaller cooling time. When you don't need the monitor, you can implement it completely into the machine and can use it with a panel of the machine, which makes it a bit easier. You have a monitor less, because sometimes when you have one for the robot and one for the hot runner, so you have 5 screens on your machine. So this is very much easier. We have different providers of injection mold machines where we can implement it completely and the numbers becoming bigger every day. So the benefits of the orcinus system, I already explained it to you. We can have a maximum of 120 degrees Celsius in standard or 180 degrees Celsius in the high temperature version. Then we have a plus version, which is not only measuring, but also you can adjust your flow. So you can say, I want a fixed flow of, for example, 7 liters per minute in circuit 2, and then the valve is opening and closing that you have straight flow of this, for example, 7 liters. Or you can say for every single circuit, I want a delta T of 1 Kelvin or 2 Kelvin, and then the plus version valve is opening and closing so that you have always a delta T of 1 or 2 Kelvin like you want. The plus version is in the high temperature version up to 160 degrees. Here you can do the settings for the plus version. So you can say, I need a delta T or the flow. And here you see the percentage of the valve. So gives you an information. Is it open? Is it half open? Or in this, it's 75% open. So you have an idea of what's happening inside. And this is when you connect our orcinus system to the TCU, then you can make the settings of the TCU as well. And if you have a pump which is not running 100% or 0, then you can say to the pump, I have green light, everything's perfect. So you only have to run on 60% or 70%, which saves a lot of energy. So the benefits of the Orcinus Plus systems are you have a very reliable process, and this saves a lot of energy and increases your process stability. So another comparison, digital temperature and flow monitoring gives you an idea of what's happening inside of your mold. With this, you can define an alarm, so you can avoid producing half a shift not okay parts, which saves you a lot of money and stress, of course, and trouble with the manager. It is possible to let our orcinus system communicate with the injection mold machine, so you have